Hello everybody and welcome to today's lesson on perpendicular lines. This lesson will conclude our unit on parallel lines, and today our objective is we will be able to solve problems containing perpendicular lines, and we will also be able to find the distance between a point and a line and between two lines. So let's first review some of our core concepts. Perpendicular lines are lines that intersect at a right angle. And always remember that right angle means 90 degrees, right? These lines intersect at a right angle, an angle of 90 degrees. So if I were to draw this, let's look at these lines. They intersect at the angle they form, and that's actually on both sides, is a right angle. The distance from a point to a line is the same as the length of the perpendicular. Remember that symbol we used for perpendicular? The perpendicular segment connecting the point and the line. Why is it the perpendicular segment? Well, let's look at a line. And we have a point here, and we want to know how far is that point from the line. I'm actually going to make that point in blue. Now, when we want to see the distance of the point from the line, I mean, we wouldn't draw a line like that. That is obviously further away, right? Or we could even go further than that. That doesn't make any sense. We want to know the closest, the shortest distance like this, and that just happens to be a perpendicular segment. The segment that connects a point and a line the shortest way is always a perpendicular segment. And that's why perpendicular is such an important concept, and we're going to look into it in this unit. Before we look at some of our examples, I would like you guys to stop the video for a second and write an example of when you would see or use perpendicular lines outside of the classroom. When in your day-to-day life are you confronted with situations involving perpendicular lines? For example, think about you are at a certain point and you want to go walk or whatever to another object, which is a line, maybe a street, maybe a river, or whatever other situation you can think of where perpendicular lines come in handy in your day-to-day life. Stop the video for a second, write that down in your left margin, and then we'll continue. All right, let's look at some examples. First, find the distance between the point and the line. So again, let's remember we talk about a perpendicular segment, and when we talk about perpendicular, we also need to remember what do we know about the slopes of lines that are perpendicular. The slopes of lines that are perpendicular are opposite reciprocals. Opposite reciprocals. So we have our line right here. So let's first figure out what is the slope of the line we have. Just pick any 2 points. For example, these two. And now we're going to count how many steps do we have to go up from one point to the next. I'm going up 2 steps and 1 to the right. That means the slope of our line, m, is equal to 2 over 1, or we could also say 2. So what would be the slope of a perpendicular line, of any perpendicular line to this line we have? It would be the opposite reciprocal. We have to do 2 things. First, we make the positive a negative. That's what opposite means. And then we flip the fraction because we need the reciprocal. In other words, the slope of our perpendicular line is negative 1/2. Negative 1/2. So now we need a line with a slope of negative 1/2, which connects our point to the given line. And remember, negative 1/2 means we go down 1 step and 2 over. That will give us another point. Now we actually want to go a little bit more to the left. So we have to go the opposite way. We have to go up 1, 2 to the left, up 1, 2 to the left. And here we have enough points which will connect our original point with the line. I'm going to draw the segment that connects these two right here. That segment, and that looks pretty perpendicular to me. What do you think? Now we need to find the distance between the point and the line, or in other words, the length of the segment. Remember, distance and length, they belong together. And yes, in order to find that length, we do need the distance formula, or if we are lucky, we go ahead and we use the Pythagorean theorem, which already uses the length of the 2 legs of a right triangle. And as you can see here, our segment and these 2 dotted lines, they make a right triangle. So let's go ahead, and here we have to just count out the length of the 2 legs rather than using the coordinates of the points as we do in the distance formula. So whenever you have a coordinate plane given, don't go all the way trying to find the coordinates and using the distance formula. Go right ahead and use the Pythagorean theorem. Does the same thing, gives you the same answer. So I'm going to count the length of this leg, which is 1, 2, 3, 4, and the length of this leg, which is 1, 2, and we know that the length of our hypotenuse, which is essentially the segment that we're looking for, is the square root of 4 squared plus 2 squared. In other words, the square root of 16 plus 4. And this is the square root of 20. Now 20 is a number that we can simplify, so we can simplify our square root. Notice that in the question it didn't give you any specifications and didn't ask you to show the answer in a specific way. So we're going to do both here. We're going to simplify our radical because the square root of 20 is the square root of 4 times 5, which gives us 2 times the square root of 5. And 2 times the square root of 5, if you were to punch it into your calculator, will give you a number of approximately 4.47. There goes your answer for the length of the segment. And the length of the segment is the same as the distance between the point and the line. Length and distance. You will keep hearing me say that over and over again. All right, let's move on to our next example. find the distance between the two lines this time. Now, to find the distance between two lines, the lines have to be parallel. Why? Well, because if they weren't parallel, then there wouldn't be just one distance, right? Actually, at some point, they would actually intersect. There the distance is 0. And then from that point on, the distance between the two lines would get further and further and further until it actually ultimately is infinity. So that makes no sense. We can't calculate that. So that really only works if two lines are parallel. And we are connecting those two lines again with using a segment. And that is perpendicular. So again, the concept we're using here is perpendicular. And I'm going to write it down one more time. The slopes of two perpendicular lines are, I can hear you say it to yourself, opposite reciprocals. Very good. So first we need to find the slope of our given line, or actually of both our given lines. So let's go ahead and do that. I'm going to pick 2 points that are on the grid line. Remember, it's always easier to use points that are on the grid line. And what do I have to do? I go down 1, that's -1, and 3 over to the right. So the slope of this line is -1/3. And just for the fun of it, let's also find the slope of that other line. I'm going to use these 2 points. They work well for me. Going down 1 over 3 to the right. And guess what? Same slope. And the same slope means these two lines are parallel. And that's exactly what we said, right? Okay, but now I need to find the distance between those two lines. And again, distance is going to be the shortest distance. We said it's got to be a perpendicular segment connecting these two. So in order to find a nice point where we can start our perpendicular segment, I'm going to use a point again on the grid line on one of those two lines. And so this segment, being part of a line that connects these two, is going to have a slope which is perpendicular to the slope of these two lines. I'm sorry, the segment is perpendicular, the slope are opposite reciprocals. And again, opposite reciprocals means this time the negative becomes a positive, the 1/3 becomes a 3 over 1. In other words, 3. So let's find the line going from that point that we marked with a slope of 3. 3 means 3 steps up, 1 to the right, and here is another point. But remember, again, we want to go more towards the other line, so let's go down 3, 1 to the left, and here we have a point that is on the other line. The segment that connects these two lines is here, shown again in pink. Don't you just love pink? Let's find the length of the segment, which is the same as the distance between the two lines. And again, using the Pythagorean theorem is always the good choice when we have points and lines given in a coordinate plane and not just the coordinates given to us in a problem. Just go ahead and again count out the two legs. 1, 2, 3. And the other leg has a length of 1. And the length of our hypotenuse, which is the segment that we're looking for, is the square root of that. The square root of 3 squared plus 1 squared is the square root of 9 plus 1. The square root of 10. Can we do anything to our 10? Split it up into factors that make us simplify the radical? No, we actually can't do that. So we're not going to use the equal sign. We're going to use this symbol to indicate that if we punch that number into the calculator, we get an approximation, and the approximation is 3.16. And there's your answer, the length of the segment, which is the same as the distance between the two lines. All right, guys, well done. Let's move on. So to finish off today's lesson, we will review constructing a line perpendicular to a given line through a point not on the line. This is a review. We have done this before, but as we are talking about perpendicular lines right now, this is a good point to review these. So remember, we begin with a line K. The line K is given to us here, and we have a point R, and R is not on the line. So remember, and we talked about this, we cannot bisect or a line. So when we do a perpendicular, we actually end up doing the bisector of a segment. So first we need to turn that line into a segment. In other words, we're going to cut off the two ends. The way we do this is we take our compass, and remember, we always start at the point that is off the line. We start here, we put the needle of our compass, the center of our compass right on that point, and now we're going to draw an arc that crosses this line in two places. And remember, I showed you one good thing to do is to just now cross out all those parts that we have there, because we don't need them anymore. We have these two intersection points, and in this example they're called X and Y. And those two intersection points, intersection between the arcs and the line, those are the endpoints of our segment. We now have a segment that goes from X to Y, and that segment we will bisect. So in order to bisect that segment, remember, we are going to draw arcs with the same length or the same radius from those two endpoints. I'm going to use those that you already see here. So from X, I'm going to draw my arc. And now, without changing the compass radius, we move our compass to the point Y, and we draw an arc from Y. We start a little over here, and here is the other arc. And those two arcs intersect. And this intersection point, we're now going to connect with R. The intersection point, and the name is B in this example. We're going to connect with our point R. Using my straight edge, I will now connect these 2 points. And there is our perpendicular to the line K. All right, again, as I said, this is just a review. We've done this. And remember, when we talked about constructing perpendiculars, what we really do is we construct the bisector of a segment. So remember, first that line needs to be turned into a segment, cut off the two ends, then construct the bisector of the segment. This is review. So we've done this before. And that's it for today, and I will see you in class.